Welcome to Summarize Science. For a long time, we have believed that a supermassive black hole named Sagittarius A star sits at the center of the Milky Way. However, researchers are now testing if this object could actually be something else entirely, called a solitonic boson star. Boson stars are theoretical, horizonless compact objects that act as black hole mimickers. They are formed by a complex scalar field and, unlike black holes, they do not have a point of no return where light is trapped forever. This makes them an intriguing alternative for scientists to study as they look for ways to explain the massive gravity at our galaxy's core. To test this idea, the study used near-infrared flare data from the Gravity Collaboration. These flares act like hotspots on orbits around the central object. By tracking the motion of these spots, the researchers could create mathematical models to see how well they fit with the gravity of a boson star. The team considered 5 different models of boson stars with varying sizes and density levels. They also compared these to the standard Schwarzschild black hole model to see which one the data favored. Each boson star model has unique gravitational signatures that would change how the flare appears to an observer on Earth. One of the most interesting differences involves light transparency. Because boson stars do not have an event horizon, light can actually pass directly through them. This creates a small, bright spot in the center of the image that you would never see with a real black hole. By using general relativistic ray tracing, the researchers generated simulated images of what these flares would look like. They then calculated the centroid, which is essentially the balance point of all the light in the flare. Tracking how this centroid moves over time allows them to compare simulations directly to real telescope observations. When they performed the fitting, they found that most boson star models required a much higher mass than what we know is at the center of our galaxy. The accepted mass for Sagittarius A star is about 4.3 million times the mass of our Sun. Most of the boson star models only worked if the central mass was significantly larger than that value. Interestingly, the study found that the fuzzier or more diffuse a boson star is, the more it looks like a black hole in images. The most compact boson stars created extra images because they bent light so strongly, making them easier to distinguish from a black hole. The more diffuse models, like the one labeled BS1, were the hardest to rule out because their results were closest to the established mass. So, what does this all mean for the future of our understanding of the galaxy? Currently, the data still strongly favors the interpretation that Sagittarius A star is a black hole. However, these results do not completely rule out the possibility of a very diffuse boson star. In the future, looking at the spin of these objects or the polarization of the light might provide the final answer. This research is a perfect example of how scientists use new technology to test even our most basic assumptions about the universe. Thanks for watching Summarize Science, and stay tuned for more deep dives into the mysteries of space.